Civil 3D tutorial for beginners. Hi viewers, welcome to my channel Survey Got Easier. Today I'm going to be sharing with you on tutorials on how to carry out some tasks as a beginners with your Civil 3D environment. Be rest assured that when you take your time to watch through the tutorial, you definitely learn on your own on how to use this software to carry out the tasks of what I'm going to be listing out for you. And also, I'll be releasing the data that you're going to use to practice on your own. I'll release that on my video description. Stay tuned. We'll be right back now. Okay, welcome back. Now, what I'm going to be sharing with you is how to import points into Civil 3D environment. That is, how to bring in data into your Civil 3D environment. I'll discuss on how to create surface, surface creation. I'll discuss on interpolation, how to carry out interpolation. I'll be discussing on how to create alignment creation. And also I'll discuss on profile creation as well as cross sections. I'll discuss on point extractions, that is how to extract points from your Civil 3D environment. Also I'll talk on spot height creation, how to create contour and true north. Now starting with point import, that is how to import points, how to bring data into Civil 3D environment. Of course, there are several ways you can bring in points into your Civil 3D environment. But before we do that, let's quickly create a new project and we do the settings, everything that is necessary for us to do. Alright, as soon as you launch your Civil 3D environment, from this place here, this is where we have the start. And if you want to create a new drawing, if you want to create a new project, you click on these plus icons. You click on the plus icons if you want to create a new project. As soon as you click on the plus icons, the next thing that is expected for you to do is to set the unit. And for you to set the unit, you can just press UN under the system. You press UN. As soon as you press UN, which is the shortcut for unit, it's going to display on the screen for you. So you'll be able to set the unit. You double click on that particular UN. So it's going to read out this page for you. You set the precisions to any decimal values you want. It can be in 2 decimal values or 3 decimal values. Depends on the type of work you are doing. You know, when you're working with a bearing and distance, you know, distance is always having 2 decimal values. So in a situation like that, you can set it to 2 decimal value. But if you want it to be in 3 decimal value, you can as well leave it in 3 decimal value. Alright, that's fine. Now coming to precision and then clockwise, you click on clockwise. Under this precision, you click on these particular ones, degree, minutes, seconds, and you ensure the unit scale is in meters. There are some countries where you deal with feet. So for countries where you deal with feet, you select feet, and places that you deal with meters, you select meters. And you come to the directions icons there, you click on directions and you ensure you set this to north. Then you click OK. Come back here and click OK. Alright, that is fine. It has been set. The next thing for you to do is to save this project. You give it a name. You come to your Civil 3D icon on your left hand side at the extreme edge. You click on it. Then you click on save. Alright, let me save it with tutorial. Alright, that has been saved. By the time you check this place here now, you will see it's going to change. It has changed. Alright, that's fine. Now coming to how to import points into your Civil 3D environment. Get that done. What you simply do is to click on this home icon here. And after you click on your home icon, you click on this point. You click on the point here. So you click on point creation tools. As soon as you click on that, you're going to have create points icons on the screen. Here is import points. So for you to use the import point, all you simply need to do is to click on it. You double click on it. So as soon as you click on import, you're going to have this. We have different formats. You can see under this place it says specify point file format. Let me explain something to you under my Excel here. In order for you to understand point format, this is data here. So this particular data now, I'm going to import it into my Civil 3D. Your data can be in Excel format. Now this data now is in a format, but what format are we having it on? This is serial number, which is 1, 2, 3, the numbers of the values, the data we are importing in. This is my nothings, and this is my easting. Why this is my what? This is my elevation, which is the height. All right. So in some cases, you might have the description that are like road, drainage, street lights, streets, pegs. You know, you get all those details. Those ones are called descriptions. You might have it under your data. Now, in some cases, you might have, there might be headings under your, under your what? Under your data, which is there will be, it's going to be XN, which is the serial number. This one will be nothings. This is going to be easting, and this is going to be the height, which is, this is going to be height, and this one is going to be the what? Description. Alright, so but you have to delete this title in cases whereby, in a situation whereby any data that you are having that you want to bring it into your Civil 3D is having title, you have to take note of this title, you have to bring it off, you have to remove the title, because if you should have title under your Civil 3D, if you should import this data like this into Civil 3D with title, Civil 3D is going to reject that data automatically. You won't be able to have access to that data. So, and after that, here we have, like I've explained, we have serial number, easting, nothings, height, and the description, which is what? P, that's the point. These are the point number. Point P, this is easting, E, N, Z, D. That's what? P, E, N, Z, D. That is point, easting, nothings, height, and description. You can also have P, and E, Z, D. And this is what? Point, nothing, easting, height, and description. You can have just easting, nothings, and what? And height, PE. You can just have easting, nothings. You can just have easting, nothings. You can have easting, nothings, height, which is the Z. You can have PENZ. These just different formats. So you have to understand the type of format that you want to bring it into your Civil 3D. I believe you are clear on the formats now. Now coming back to our Civil 3D environment, from what I just explained earlier, so you should be able to understand the type of file formats that you want to bring in. And you have to what? You have to close whatever you already have on your the data. Peradventure you already opened the data on Excel or anywhere, maybe Excel or Notepad. You have to close that particular data that you want to import into Civil 3D, because if you don't close it, it's not going to run on Civil 3D. So, and that's what I just did now. I did what? I just closed it. So checking the format that we have the format as PENZ, that is point, easting, nothings, height, and descriptions. PENZ. So all I'm simply going to do is, under this specified point file format, is to select the appropriate format of data I want to import into my Civil 3D, and that's what? PENZD. Like, okay, let me quickly also share you some other things. This particular data was saved with CSV command delimited, and for you to save the data with your Excel with CSV command delimited, all you simply need to do is to click on file, you click on save as, and you come to browse, you click on browse. So under the browse now, you can see CSV command delimited. This is it here, CSV command delimited. And that's how to save a file that is having an Excel format in CSV command delimited. And that's why you've seen it here, command delimited. I believe you can see command delimited. We also have space delimited, but we are working with what? We are working with command delimited. Alright, so for you to do that, you're going to locate command delimited data format. We have space delimited and we have command delimited, but the one I'm going to be using is because it's command delimited, because the data I'm bringing in into Civil 3D environment is command delimited, and that's why I'm going to be using that. Alright, this is command delimited data, PENZ. You can see we have PNEZ, but for PENZ, this is PENZ command delimited. Then after you select this particular data format, you click on this place here, you click on this manage format. then you come back and select that particular format again, PENZ, comma delimited, and click on modify. Alright, as soon as you click on modify, now you can see default file extension, and this is where Notepad comes in. You can see .txt. If I should open this data now, this data is an EZ data. You can see we are having it as well .txt because it's a Notepad data. Sorry, this data is a Notepad data, so it's having .txt, and that's what we definitely have here, .txt. If it's a Notepad data, you set it that it's a Notepad data. You have to let the system understand that this data you're bringing in is a Notepad data. This data you're bringing in is a CSV data, that is EZ data, CSV.csv. But the one I'm using currently is CSV because I save it with CSV format. That's comma delimited, CSV comma delimited, and you click on coordinate zone transform. So you click on load, and then you select where you have your data. You come to this files of type. If it is CSV, you select your CSV. If it is a text file and that's TST, you select the TST data that you want to bring in. And then after you select it, after you are done selecting it, you click on open. You also select, if I should change this now to TST, you see what we are going to have. You can see, because under that folder I don't have any data that is having TST file format. That's why it's not showing. But because under that folder all my data was saved with CSV command delimited, and that's why you are seeing this on the screen under the folder CSV. Everything is CSV. So any one of my choice, parameter, I want to use anyone, I'll just select it. As soon as I select it, then I'll click on open, and it's going to open automatically for me. And as soon as it's open, I'll click on load, and then it's going to open. Then as soon as it's open, I'll click OK. Alright, if I should click OK now, the next thing for me to do is to come to this place here. I'll come to this place, I'll select it again, and then I'll click on open like I've done earlier on. I'll click on open, then after I click on open, it's going to load. Then on this place here, it's going to mark it, it's going to check it in. We are going to get in there. I quickly want to share another method. I want to show you another method that you can use to achieve that, to get that done. Another method that you can use is, instead of you coming to this specified point format, since you already know your format, your data format, that the format, since you already know the data format you want to bring into Civil 3D, you already know how data is arranged, you already know how it is being arranged, PENZ, EMZ, PNEZ, and likes. So all you simply need to do is you click on this plus icons, add files. So as soon as you click on add files, you select it here under the file type. If it's a CSV like I've explained earlier on, you select. If it's a TST, you select, and you come to the location where you have the files of whatever you want to bring in. You select the location where you want to load the data. Alright, so you select the location where you want to load the data. So we are working with this data now. We are working with this data XYZ. So I'm going to click open. So as soon as I click on open, you can see now it has opened. Now we have it listing notice, points, elevation, and descriptions. You can see now. So all you simply need to do is to select it from here, PENZD, command delimited. So you locate PENZD, command delimited, and this is it. You can see it has, if you should check the screen, you can see it has highlighted it. So you select it, PENZD, then you click on add point to point to. In the cases whereby you want to bring in a lot of data, it's not just a single data you want to work with, you can just come to this place and you click on this plus icon, you click on it, you click on maybe data 1, like that you get, so that you'll be able to identify your data. If you want to bring it off, you'll be able to bring it off, and it's not going to affect other data. Then as soon as you are done, you're just going to click on what? Click on OK. Alright, so the data is going to load for you on the screen, and after the data has been loaded, successfully loaded, you can come to this zoom extent. You just click on zoom extent. As soon as you click on zoom extent, automatically you have the data. Or as well, you can as well come to this place here. You just press, you can come to this your command buttons here. You press Z, enter, and you press what? E, enter. So we have the data now. This is the data that was just imported to the screen, and that is how to successfully import data into your Civil 3D environment. Now let me quickly share with you on how to fine-tune this data, how to make your data look more presentable. Starting with this place here, from here I'm going to change this to 1 in 500, because data is looking just choky, like data is just as if everything has matched on each other. So to make it look more presentable, that's why I'm doing that. Then after that, I still see some things that we can just work on to do other settings. Under these point groups here, you click on this plus sign beside the point group. You can see this is the data that we created a name for the other time. This is it here. This is it here. And if peradventure you have subsequent data that you imported in, is going to display here as well. And this is where we have all points, that is all data that was imported into the system. So coming to this place here under the data, when I right click and click on properties, I can do any settings, how I want the data to look, how I want it to appear. We have basics. Under the point style, we have basics and lines. You can just turn off under the point style. If I should click on none and click on apply, you can see now, you can see those points is not longer showing, and that's how to turn off points. If you don't want point to display on your screen again, you can just turn it off. Well, let me bring it back. You can see now those points has been brought back to the system. And under this point label style, we have several point label style that you're going to tell the system to display for you. If you don't want any point style to be displayed, you just click on none and you click on apply. So you can see now the point style has been removed from the screen because it was set to none. Now if you want to display the point style to be if you want to display the point style to be only description only, we have several point formats, description only, and that's the details like road, all those things, you know, road, street light, pegs, streets, drainage, canals, borehole, and lights. Elevation and descriptions, we have elevation and descriptions, that's the height. If you want the height to display, you can set that as well. We have elevation only, we have nothing and listing, but I'll leave it at what? I'll leave it at points, elevation, descriptions, and I'll click on apply. So we have the point, that is each number of those particular data that was reported in. You can just select it. You can select it, and as soon as you select it, it's going to display. Alright, so there is a icon here. Under this icon, press the down buttons, blah blah blah. When you click on it, now when you click on that, it's going to display this point label style. You can do any editing, how you want the point to be displayed on the screen. You can definitely set that the text height, the rotations, the angle, the offset, colors, and every other things. By selecting this text height, if I want this text height to be reduced, of course I can just set it to be 1, and I'll click on apply. You can see now it has been reduced compared to what we had before. And then I'll click OK. Now when you click on apply now and check this place, you can see the point style has been reduced. Also for the basics, when you click on, the basics is deals with the, you can see the basic deals with the points. So under this place here, if you should change this scale to, let me change this scale to 0.7, and let's see what it's going to give us. You can see it has been reduced now. When you click OK and you click on apply here, you're going to see the changes on the screen as well. And that's how you can definitely work with your data. Anytime you bring in data to Civil 3D, you can set it to any format. You can display it in any way that you are interested in. And that is how to import data into your Civil 3D environment. Now going to the next task we have on the list, and that is surface creation. For you to create surface on Civil 3D, you come to this surface here, you click on surface and you click on create surface. So when you click on create surface now, when you click on create surface, this is create surface. So under this name, you give it a name. Maybe you can just give it surface 1, name it as surface 1, and we have style, we have descriptions. You can give it description if you want to give it any descriptions so that you'll be able to identify it, but with the name you are good to go. We have style, we have different style. Under this style here, we have style and render materials. When you click on these 3 icons beside the style, it's going to bring out this page, and you click on this place here. We have a couple of style surface. We have no display, we have border only, we have contour 1 meter and 5 meter background, we have contour 1 meter and 5 meter design and likes. Whatever surface that you create for each of the folders that you imported in, each of the data that you imported in, and you use the style. If you, peradventure, you know the default style that we have here now is on contour 2 meter and 10 meter background, and we have the render materials as well to be on the same thing. So, and that is for what? That is for data here. That's the surface for this data. And if you are going to import any other data into this environment, the style that you're going to be using should not be the same thing with this particular style, because if you are using the same style for this data, any changes that you want to carry out is going to reflect on the other data that you import into your system. And that is why you have to use different style for your surface, and that is why you have to use different style. So after you are done, you click on OK. You can see surface 1, you click on OK. So surface 1 was created successfully. So you come to this plus icon beside your surface, and this is the surface that was just created, surface 1. So this surface is yet to be completed because we've not add any data into the surface. So for me to add data into the surface, all I'm simply going to do is to click on the plus sign beside the surface, and I'll click on the definitions. Then under this, we have point groups and we have point files. For you to use point groups, so let me show you. To use point groups, you select it and you click on right click, you click on add. So if you should click on add now, you can see now we have data. These are the data that was imported into your Civil 3D environment. You can bring in this data to create surface automatically. That is, you want to use this data to create surface because you've imported it into your Civil 3D before. You just select it and you click on apply, and the surface will be created automatically. You click OK, and when you see now the surface, the data has been added to the surface has been created, and you've added the data into the surface. And that's why you can see on the screen we have these surface designs on the screen. And another way of getting it done is in the cases whereby I've removed the surface that was just created. So in the cases whereby I don't want to use the surface that the data that I imported into my system, into my software, I don't want to use that data, or I want to bring in the data in another way. All I'm simply going to do is to click on these point files. I'll right click and I'll click on add. So as soon as you click on add, you're going to bring in the data just like the way we import the data into the system the other time. You select it. You know, this was the data we worked with the other time, and you click open. So you select it, and it's going to bring the data for you. You select the data format from this place here, and you click OK, and you're going to see on the screen we have the data. And that's the two ways of how to add data into your surface. Now when you right click and you click on edit surface style, under this edit surface style, you're going to have this on your display on your screen. You're going to have this as a display on your screen. Now whatever things I'm going to be doing here is going to be reflecting under this place. This particular boundary that you can see on green here, which is the border. You can see it on green. If I want to change the border of the surface to red or any color of my choice, I can definitely do that. I've changed it to red. By the time I click on apply, you can see it has been changed to red. If I want to turn it off, this is it. This is a globe visible. You can see visible here. If you should turn off this globe now and you click on apply, that is, you've turned off the border of that surface. You have the major and minor contour. You know, if I want to turn off this contour as well, the major and the minor contour, you can also turn it off. You can see the color of the major and minor contour. So let me just change the two colors so that I'll be able to identify the two color contours, the two major contours and the minor contours on the screen. So when you click on apply now, you won't see it because I've turned off the globe. By the time I turn on the two globe now and I click on apply, you can see the major contours and the minor contours. That's it on the screen. This is it on the screen. And we are still coming to that place. When we are working with contour, you're going to see that as well. We also have some other things on the screen that we can turn on. We have the water sheet, we have the slope arrow, we have the slope, elevation, directions, grid, and every other things. By the time you turn it on, you're going to see the points, triangles, all those things. When you turn it on for the surface, you're going to see everything on the screen. It's going to display for you. By the time you turn it off one after the other, you also have everything. It's going to be reflecting on the screen, and you're going to know what each of the points, each of the globe you turned on is standing for. What it simply means: directions, elevations, the water shade, we have the slope, and this is the slope here. I believe you can see those arrows. Let me turn off this water sheet and see. This is the water sheet. The water sheet has been turned off. So this slope arrow is this arrows you can see on the screen, and this slope as well is the slope directions of those arrows. Also, we can also turn those arrows off. The slope arrows, you can turn it off. The point as well, the points, you can turn that off as well. That's that, and I'll click OK. And that is how to work with your surface. The next thing we have on the list is interpolation. And what was interpolation? Let me quickly explain with this particular data we are having on the screen. This particular area that is empty now, we don't have any data on it, but we have data within the surroundings, but we don't have any data within this space here. Now, interpolation simply means that with this previous data we are having within this range, within this environment, we can use this data to interpolate, to add and other data to this environment. That is, with this data we are having on these areas here, we can generate data through this data we already have before to these areas that is blank. And that's why interpolation simply means that is, you are introducing points towards data you have before. You are adding more data to it. So for you to carry out interpolation on your Civil 3D environment, it's quite easy and straightforward. Of course, I'm still going to be sharing with you on working with spot height. Spot height is going to let you to use interpolation as well. You can carry out spot height with interpolation, but we've not gotten to that place. Now, for you to carry out interpolation, the next thing for us to do is to come to this point here. You click on this drop down arrow, then you click on create point interpolate, then you click on interpolate. Alright, you come to this place here, you click on surface on grid, then you click on this point creation. So under this point creation now, you can see we have a couple of things here. We have point creations, we have local coordinates, we have grid coordinate and likes, we have the geographical coordinates, we have front elevation and every other things. We have default style, we have default name, we have point identifier and other things. But for this prompt for descriptions. If you want to create the, if you want to interpolate the data manually, that is, you'll be the one to select the area where you want it to be interpolated, you click on manual. But if you want it to be automatic, you select the automatic. So I'll be using manual method to do the interpolation. I'll click on manual, then after that I'll click on this place, this grid. I'll click on it. So the next thing the system is telling us to specify a grid. The system is telling us to specify a grid base point. Alright, so I'm going to specify the grid base point. The grid base point is important for you to know the area where you want to select. If I should select this grid base point, or if I should select this place here, it's going to start the interpolation from this place, this particular point, at any interval I allocate for the interpolation. And if I should start within this area, it's going to start the interpolation within this area. Any area where I select the grid base point, that's the area where the interpolation will be starting from. So let me just select this place as my grid base point. Then it's asking for rotation. I'll leave it at 0, and the interval spacing for the grid X and Y, let me use 10 meter interval, 10 meter interval for the grid of X and Y. Then I press enter for the grid of X and Y. So the next thing is to select the upper right locations, which is here, and you click on no. Change the size or rotations, no. Then it says what, enter a point or descriptions. So you can see that box that showed the other time, that's where it's going to start from. I'll select here and I'll press enter. Now you can see now this is where the interpolation is starting from, and then I'll press enter for the next point. At every 30 meter interval, that's where the interpolation is taking place. At every 30 meter interval, the interpolation is taking place. You can see the screen. At every 30 meter interval, the interpolation will take place. You can see that on the screen. You can see the interpolation now on the screen. The spacing that was shown as the grid spacing the other time on the box is where the interpolation is taking place. You can see the screen. I believe you can see the interpolation, and there are other ways you can carry out your interpolation. This method I'm sharing with you, you can export this data as CSV, just like the way we import the data into Civil 3D. You can also export it out. When we get to spotlight creation, you also see other ways to carry out interpolation. So, and that is how to carry out interpolation using this method. And the next thing we have on the list is alignment creation. Alright, I'm going to be using this data to create my root alignments. Now, creating alignments on Civil 3D, this data has been imported into your Civil 3D. Alright, the next thing for you to do is to use your polyline to join the points together. Alright, to do that, all you simply need to do is to press PL. PL is the short form of polyline. This is it here. You click on it and you select the starting point. So I'm going to be starting from here. I'm going to turn on my O snap. So starting from this place, I'll select Alright, then I'll press enter. This point has been joined together with polyline. So this is where we're going to be creating our alignment on. Alright, the next thing for me to do is to click on this alignment. So I'll be working with this create alignment from object. I'll click on that. I'll select this polyline. I'll click on it. Under this page that says select lines, or hack or polylines to create alignments. I'm going to press enter. Now what this arrow simply means, this arrow that you can see here, what it means is that it's going to start its stations from this point to this point. But in the cases whereby you don't want the system, the software to start the stations from here to here, that is from up here to the example, that this place will be 0, 5, 10, 15, like that to this place. If you want it to start from this down part, all you simply need to do is, you can see it has stated it here for you. Press enter to accept alignment direction, or reverse. If you should click on reverse, that is, it's going to start from this place to up here. And so I'll be using this particular pattern, this arrow selections. I'll press enter because I'm satisfied with the way it is. So now you can just give your alignment a name. I'll name it as road, and under this general we have general propose. Yes, is a propose. If it is an existing road, you click on existing. If you want to create an offset, you click offset, and those other things. Sets. I use major and minor labor. Add curve between tangents. Use radius of 200. You can change it, and subsequently you can change it anytime, even after you've done with the alignment creations. You can change it later in the day, and you click OK. Alright, so you can see now, like I've said earlier on, starting from this place, 0, 20, 40, 60, 80, 100, 120, 40, 140, 160, 180, 198. So the total width of the road is, the total length of the road is 198 meters. Alright, that's fine. Now these particular chain edges, let me quickly show you on how to edit your chain edges, how to edit your alignments. Now when you check this, now when you click on that, you click on it and you right click on edit alignment style. Yeah, you can change the alignment color. Let me move this towards this side. You can change the alignment color to any color of your choice. Then you click on what? You click on apply. You can see it has been changed from green to red. We have the curve, the spiral. You can turn them on and off by on this globe. If you don't want the spiral to show, the curve, all those things, line extension and lights, if you don't want it to come up, you can just turn off the globe, and after you're done, you click on apply. And that's how to work with the alignment, the lines itself. Now working with the text and other things. Now if you want to work with the text, you can just press ST. When you press ST, tel star, you select LST, and the text star is going to come up. So the text style that you can select any text style of your choice. Let me use Family Romance. Then you click on apply. You can see the text height on the screen now has been changed automatically. Doing other settings with the alignment, when I select this, I'm going to right click and then I'll click on edit alignment labels. Now this is good. Coming to this place here, we can edit the alignment labels. We have label styles. We have different label styles. We have perpendicular with stick, we have parallel with sticks, we have, well, let me use parallel with stick and let's see what we're going to have. So let me first delete this that was there, the one that was there that we have initially. Now we have major stations parallel with stick. So the interval is correct, was on 20 meters. So if you want to change it to like 25 meter interval, you can do that, which you are good to go. And after you're done with that, you can come to this place here. You come to this place, you click on that box, and under this place you select the test height that you want. If this test height is small, you can use a bigger test height, like maybe 5 for the test height. So let's use like 3, and the rotation maybe 180, 90. So now 90. Then this offset, now you can change the offset. Top center, you can see top center anyhow you want it to be displayed. Top right, anyhow you want it to be displayed, you really want to select that. Middle left, this one is okay. You can also play with the offset. You can play with the offset how you want it to move, which is okay. Also the background color, the color, let me use other colors. Okay, let me click on apply. So let's see what we have. Then you click OK, you click apply, you click OK. Alright, so that is that on that. Now you can see now the tests, you can either edit in both ways, using the ST method and using the other method I use, that's edit label style. Now you can see now it's currently on 25 meter interval. That was what we just changed now to 25 meter interval. You can also change this radius and curve. You can change the color, or you can turn it in or turn it off if you like. And that is how to create alignment on Civil 3D. Alright, the next thing we have on the list is how to create profile. Now for you to create a profile, you must have created an alignment. You must have created a surface and alignment. So from the alignments that you create, you'll be able to create your profile. Now because we've created a surface, we've created an alignment, the next thing is for us to create a profile. Now for me to create a profile, all I'm simply going to do is to click on this profile. So you click on create surface profile, and then you select the surface that was created. The surface that was created, that's what you select, which is what surface 1 that we created at first during the time I was sharing with you on how to create a surface. So you select that because that's the surface of data that we are working with. So you select that particular surface and you click on what? You click on add. And the alignment that we created was what? This is it under our alignment. You know, we named the alignment to be road. When we created the alignment, we named it as road. So this is it. We have several alignments on the screen that you are working with. Maybe you are designing a different type of road sections. You might have different roads. So you really want to select the road that you want to work with. And you can see here that says alignment starts and end. If you want to generate a profile for a specified place, region, you can just start on a particular place where you inform the system to create profile from, start from so place, end at so place, and to sample as well from so and end at so. Now this is the profile that we selected, the surface that we selected, and you click on draw in profile view. Alright, so we're going to add this and we click on next. Alright, so this is automatic, but if you want to specify these areas, you just click on specify range. But we want to work with the automatic, so we click on next. We click on next, and we click on create profile view. Alright, so the system is telling you to select the place where you want the profile to be created, so I'll put it here. So now this is the profile. We've created the profile on the screen. You can see road profile. That was the name we used for creating the profile. Now on our advanced class, I'll be discussing further on how you can work further with a profile creation. So for now, we're going to stop on this particular note. But before we stop, let me quickly show you on how to edit. Alright, so you can see this is the name of the road, of the alignment. You can see road. Now you can change this particular road profile station. You can change the what? You can change the settings, the stations interval from 20 meters to 25 meters, as we've done for the alignment as well. You just select and you right click. So you click on edit profile view style. So you come to this place, you click on this, you click on horizontal axis, so you change this to 25. It's currently on 20, you change it to 25 and you click on apply. So you click OK. I believe you can see now it has been changed from 20 meters interval to 25. You can see 0, 25, 50. Also, you can also change the grid that you have by selecting it and you click on edit profile view style. Edit profile view style. So you come to this, you click on grid, you click on this clip vertical grid and this clip horizontal grid, click this, click on apply. You can see what we have. On our advanced class, I'm going to be going deeper into these sections where you edit your profile properly, but for now we can just leave it for now like this. Alright, so and that is how to create profile using your using your Civil 3D software to create profile. Before we go to cross sections now, which is the next on the list, let me quickly add something to this alignment, which is offset. So with this alignment now, if you want to add an offset to your alignment, all you simply going to do is to come to this alignment. Here you click on the alignment, then click on create offset alignment. Alright, so you select what it says, select an alignment or press enter key to select from list. So we already have this as a single alignment, but if you have a group of alignments, when you press enter, you'll be able to select the one you have. When I press enter now, you see it's going to show the alignment road that we created the other time. Peradventure, we have multiple alignment that was created. You're going to see it listed out on the system. So you just select the one you want to create an offset for. That's fine. So you click OK, and as soon as you click OK, you're going to have this on the screen. So you can see alignment to offset. That is, it's telling you this is the road where you want to create alignment, which we saved as the road the other time. Now we have from start, we have to end area where you want to select the alignment, the offset to be created, if need be, and we have what number of offsets to the left, number of offsets to the right. So this offset now you can create 2 offsets, 3, 1 alike, anyhow you want it to be, but I'll leave it on one offset to both sides, the left and right. And this is the increment offset. This is the I'm going to select 2.5 for my distance of the distance offset of the distance. I'm going to select 2.5 for the offset increment. Now under this alignment label set, I will be selecting no label. You know, the other time when we created an alignment, we use major and minor only, but here I'll be using no label because I don't want the system to label the offset that we're going to create. And I'll click OK. Now you can see now the offset has been created successfully. Now coming back to the cross sections that we want to create, like I said, you have to have an alignment for you to create a cross section. Now when you click in order for you to create a cross sections, all you simply need to do is to click on sample line. Alright, so as soon as you click on sample line, it says select an alignment or press enter to select from the list. We press enter. Oh yeah, select for us. Let's see what you're going to select. Now you can see now is now, it has given us the offset that we created. Is it the offset that we created that wants to create a cross section for, or is it from the center line? So I'll be using the center line as the offset to generate my offset. So I'll click on this road. You know, the road was named with the center line. Then I'll click OK. Now we have this as the name, SL Collections. Let me name this as SPL. Then alignment as road. So this is sample line label style. I'm going to select none that I don't want it to display. Then I'll select this and click OK. Now you're going to have this now. Under this, here we have by range of station, we have at a station, pick points on screen. So by range of stations now, when you click on by range of station, we have this is going to come up. Under by range of station now, we can create the sample line. When you click on this by range of stations, so we have, let me expand this. We have left field is 5, the right is also 5. Here we have the increment and long tangents, which is what, 25 at every 25. Then I click OK. Then when I'm done, I'll click on close. Alright, so we've created the sample line. The next thing for us to do is to create the sample view. Alright, so this is the sample view here. We click on it, you click on create multiple views, and then you select the stations range that you want to create sample views for. You click on, you can see this is the automatic. If you want to specify, you click on specify. Then you click on next, then create sample view. Alright, so you select the place where you want the sample views to be created. Now this is the sample view. Now we now have the sample view on the screen. Now on the advanced class, I'll be touching on how to edit your sample views with your profile. And the next thing we have on the list is point extractions. So for you to extract points on Civil 3D, peradventure in the cases whereby you already have point on Civil 3D, you want to export point out of your Civil 3D, like the interpolations points that we generated the other time within this case space here. So you want to export out those points. All you simply need to do is to select the point that you want to export out. So I'll select this range point here. I'll select this point, and all I'll simply need to do is to right click and I'll click on edit point. So under this edit point, I'll press Ctrl A. So I'll right click and I'll click on export point. So under export point now we have point formats. You can select the format of the points that you want to export. We have different formats, like I've put it through on this format that we have PNZD and likes. You select it, and then you select the location where you want the point to be exported to. You select the location which you have here, this destination folder, and after you select, you click OK. So after I click OK, you give it a name and it will be exported to the location where you have, where you select. And that is how to export points from AutoCAD Civil 3D. For now, we're going to be stopping here. On our next video upload, I will continue right from where we stopped. Don't forget, I'm going to be dropping this data that we used to carry out this exercise on my video description for those of you who might need it for practice. I believe with this explanation, you should be able to sit on your own and to get this done. And if you are having any issues, if you are having any questions, you can always reach us through our mails. On our video about, you get information on how to reach us on how to communicate with us. You see links to join our groups and likes. And if you found this video helpful, do well to subscribe to my channel, like my video, comment and share. Also, don't forget to turn on your notification bells to be updated whenever we upload videos on our channel. Thank you. Welcome back to class. Today we are going to continue from where we stopped on our previous class on Civil 3D tutorial for beginners. On our previous class, we stopped at point extraction, so we are going to continue from there. The next thing we have on the list is spot height creation, and that is how you can create spot height. So for you to create spot height, what you simply need to do is to have your data XYZ, which I already have on my screen here. This is my data. This was the data we were using on our previous class. So after having your data, you must have created a surface and add the data into the surface, which we've done on our previous class. So when you check here now, we already have a surface. This was the surface we created the other time. Alright, so now since we already have that, the next thing is to create spot height. Now we are going to create spot height for this data now. Now for me to do that, to engage into that, what I'll simply do is to come to annotate. And as soon as you click on annotate, you're going to come to this place that says add labels. Alright, you bring your cursor to add labels, you click on the drop down arrow. So under the drop down arrow, you're going to click on surface. So this is surface here. Surface, under the surface, we have several options. We have add surface labels, slope, we have spot elevation, we have spot elevation on grid, you can see contour multiple and likes. So we're going to be working with spot elevation on grid. Alright, so you click on spot elevation on grid, you can see it says create spot. When I hold my cursor into that, it shows create spot elevation labels on a specified grid overlay on a surface. If you should check this now, this one says create spot elevation labels at specified points on a surface. That is, you want to specify a point on a surface if you want to use this. But if you want to use this, that is, you are specifying grid overlay on a surface. So I will make use of the two and we're going to see the differences. So let me make use of this at first, spot elevation on grid, and let's see how it's going to be. Let's see what we're going to have. So I'll click on that. Alright, if you can remember on our last class under the interpolation, I told you I'm going to furthermore when we come to spot height, and this is what we are doing now. So just pay attention to what I'm going to do. So it says specify a grid base point. Alright, so I'm going to be selecting here as my grid base points. So this is my grid base points. Now under this place you can see grid rotations. So I will use 0 as my grid rotation. I'll leave it at 0, then I'll press enter. Now grid spacing for X and grid spacing for Y. So I will use 10 meters for my grid spacing for Y as well, which is 10. Then it says specify upper right locations. This is my upper right locations. I will come to this page. It says change the size or rotations of the grid squares. I will click on no, and we are going to wait for it while it supply us the spot height values. Alright, so these are the spot height creations. You can see now this page that does not contain values before as contains values now. We already have values inside this data. Inside this data, with the data that was supplied in, we are able to generate spot heights with the data that we have. And this particular data now, if I want to edit this data, all I'm simply going to do is to select one of the data now. I'm going to right click and I'll click on edit label style. So under this, I'll click on this place here, and here we go. We have this content and likes. You can change the text height If it's not bold enough, you can increase, and if it's too bold, you can decrease. Under this content now, you click on these three dots, and here we go. You can bold, you can select this, you select wherever you have here, and you click on this place format to change the text height of whatever you have. I'm going to use Times New Romans, and you can as well change the color. And when you're done, you click on OK. You can see it has been bold. Then I'll click on apply and I'll click OK. Now you can see now it has been bold from what we have before, and you can as well change the rotation as well. Now that aside, let me just delete everything we've done so far. Coming back and checking what we have under the label surface. Now let's check these spot elevations. You know, we used the other one, spot elevations or grid before. So now we're going to select this, select a point. We should select a point. Now this is the point we want to select. You can see it's quite different from what we have before. Now I believe you can see this is quite different from what we did earlier on. Spot elevation on grid is quite different from spot elevation. This is going to let you to supply in your values directly as soon as you reference a point. So you can see the difference now, and when you are done, you press enter. And if you want to edit as well, you will definitely do it just like the way I edited it the other time. And that is how to work with spot height creations if you don't want to use the other method I use for interpolation. And that's fine. The next thing we have on the list is to create contour. And for me to create contour, you know, like I said earlier on, you must have created your surface and add your data points into it, which we've done. Now is to create contour, but before I start creating my contour, you must on your contour. You know, during the surface creation, I share with you on how to turn on your contour, how to turn it on through the globe visibility. So that's what I'm going to be doing. So I'll come to this surface, I'll click on the plus sign beside the surface. Then we have this surface that we created, surface 1. That's what we created. So I'll select it and I'll right click and click on edit surface style. Alright, so now you can see these are the contours we turned off the other time when we created surface. So I'll turn it in order for me to create my contour. And then I'll click on apply. As well, I'll turn on my border. So this border now, I'll change the color to this default color that was there earlier on. So we have the major and minor contours now. So, and another thing I'll be sharing with you is under these contours here, you click on contour interval. So you scroll down here, under the contour interval, you select the contour interval that you have, the base elevations, the major interval, the minor interval, and the major interval. Now, for the major and minor interval, whatever you use is very important for you to know. And under the contour smoothing now, I'm going to click on the plus icon beside it, and I'll change this to true. After changing it to true, I'll increase this contour smoothing. And I'll change this to spline curve. Alright. And I'll click on apply. Now you can see now the contour has added more. And then I'll click OK. So let me quickly turn off the points that we have on the data. the laser point, so that we can work directly with our contours value. We can see it clearly. You know, I've put you through on how to turn this off during the import sections, during the time I was showing you on how to import data. So that is that. So we've turned it off. Alright, so the next thing for us to do is under this surface now, you know, we've turned on the contour now. So you click on this surface that we created, that we already have data inside it. You come to this place that says edit, you right click on your edit, and you click on this smooth surface. You click on smooth surface and you select this grid base. Then you come to this select output regions. You click on these three dots. Alright, you come to this surface boundary now, the surface border. You select it and you click on what? You click on surface. Alright, so it's going to select automatically like that. So under this grid spacing, I'm going to be using the grid spacing of 10, as well as this. Now I will use 10 for this as well. Then I will come back to this place and then I'll click OK. So now that we have this, the next thing for us to do is to come to this annotate. You click on annotate, and then you come to this add labels. You click on it. So under the surface now, you click on add surface label. Alright, so this label type now, you change this label type to, you can see we have single contours and multiple contours. So I'll be showing you the two difference, the difference between the two. So starting with contour single, I'll select contour single. Now under this major contour and minor contours, you can see major contours label, minor contours label. You do the settings by coming to these icons, press down arrow, you click on it. Alright, so you can see from here, you can change the text height. You can change the text height. Let me change the text height to 3. Now you can see this is the text height for the contours. And then when I will click on this content under these three dots, now if I should click on these three dots, you select this and you click on, you select this and you click on format to come to format. So you change this text height. You can change it to any text height. This color now, I'm going to change this color. I'm going to change it to contour color, and contour color is brown. Hope you know. So I'll select brown color. Then I'll click OK. So I'll click OK here as well. You can see now it has been changed to brown. So I'll click on apply and I'll click OK. So that has been set. You do same things to the minor contours. You know, the one we did was for this one, for the major contours. Alright, so this one as well, you change to 3. Then you click on these 3 dots, select this, and you come to format. You change this to Times New Roman, any text format that I used to use. So you select the color. You have to use different color because you know we have major contours and minor contours, and it's not supposed to be same colors. So but you have to ensure you are using brown as well, but just that the color will be slightly different from each other. Then I'll click OK. So I'll click OK here, and here again I'll click OK and apply. Alright, now I think we are good to go for single now. When I click on add now, when you click on add, so I'll just click here. It's going to what? It's going to display the contour values. You can see the contour values now. This is for single. You'll be the one to be selecting wherever places you want the contour to be displayed on the screen. And that's just the difference between the single contours and multiple contours. Now working with multiple contours, when you click on multiple contours now, when you click on multiple contours, after doing the settings and you click on add, so you're going to see the difference of the two now. If I should select this place here, and you see it's going, you have to select it along the path of wherever you are selecting. It's going to what? It's going to pick the whole, give the whole contour lines values automatically, and that's multiple. So that's why it's called multiple. You can see everything is together compared to this single contour that we input one after the other, and that's the difference. And that is how to add contour intervals to your work on Civil 3D and to show contour lines. I believe by the time you sit down to practice both the tutorial 1 and the tutorial 2 that I've shared with you, you'll be able to get it well. And don't forget, I'm going to drop the link for you to download the data that I used to carry out the exercise on my video descriptions. Alright, and if you found this video helpful, do want to subscribe to my channel. Easier. distance is 40. coordinates, to locate your coordinates on the N O N N. Then I'll rotate now. This is how to plot a control connection plan, a key plan. Thank you. Hello subscriber, sending a layout. Your layout must be in the direction of the boundary. It must align with the boundary. What I'm saying is that looking at this boundary, this one that has been designed here, you can see this line. This line is also aligned, is in the same bearing. It's hardly same bearing as this. This is the line I'm talking about. This line here. When you look at it well, you can see it's also formed with this line on this place here. designing exactly a layout of 1000 square meter. 1000 square meter, or a little difference from 1000 square meter, just like the way this one is, depending on the size. As I've said, at times when you are designing a layout, it can be on the plot of land which is going to be by So for a plot of land length and breadth is 18 by 36. That is for the length and breadth. But I'm not going to be designing based on plots. What I'll be designing is going to be on based on square meters. 1 in 1000. I'll be using 1000 for my size. So for me to do that, what I'll do is I'll offset this line. I'll offset it out here, and then I'll bring out my road. So for me to do that, I'll click on my polyline, and then after I click on my polyline, I'll bring it out towards the end. So I'll click on offset. Then after drawing out this line, so let's check the distance for this line. Distance for that line is 410. So for us to have one in 1000 square meter per plot per size. So let's quickly do the calculation. So you bring out your calculator, you open your calculator, you should use 40 multiplied by okay. 40 multiplied by 25 is 1000. So for that, I already said the length for this side is 410, so it's going to be 410 divided by 40. So what do we have? That is 10.25. So we are going to have roughly 10 sides for this area here. I'm going to have 10 passes for this area here, for this block. So let's do that. Now let's offset 40. We offset 20. The length is going to be 20, while the breadth is going to be 40. So click on offset under your command. Select your offset. It's asking for offset distance. My offset distance is my offset distance is 25 because it's 40 by 25. So I'll press enter, and then I'll select the side I want the offset to appear. So it's on this side, which is 30. Then after that, I want to offset this. I'll draw a line. I can just come to this place here. I'll click on polyline, or you can come to this place, select the one here, and you press enter. So you offset this by offset. You click on offset, and then select your offset distance as 40. 40.0. So I'll click on this place. I'll select it again. Another 40.0. I'll select it again. I'll select it again. I'll select it again. After you're done, you click enter. So what you simply do is that you extend all the offset line here to this place. So you can just select this place, you select it, and then you press extend under the command. You click This is how to create a layout. Thank you. So let's off our host now. We can undo this. Is Thank you. Hello, welcome back to my channel. Today I'll be showing you on how to scale a plan, either one in 500, one in 1000, one in 2000, one in 5000, 10,000, 20,000. After you finish plotting on AutoCAD, for one in 500, this is the border for one in 500. This is your boundary. Now you are done plotting. So the next thing is to put it into scale, either 1 in 500, 1 in 1000, depending on the scale that's suiting. The lowest scale is 1 in 500. If the boundary is too big, so that does not support 1 in 500, that is when you have to consider it to put it on 1 in 1000. If 1 in 1000 is small, you change the scale to 1 in 2000, like that. So now let's assume you are done plotting this boundary. Now you want to put it into scale. So the first thing is you have to test scale of 1 in 500. For the scale of 1 in 500, now we have, for 1 in 500, the length is 156.638, while the breadth is 96.872. Now let's assume you are done plotting. Now you are done plotting your boundary, so you want to put it into scale. So what you do is you click on your polyline, then you select auto, and then you press your distance that you want. That is, what is the distance? For the length is 156.638. Then you press 156.638, enter, and then for the breadth, that is 96.872. Press your polyline again, then you select this 96.872, enter, escape. So after that, you come to rectangle, and then you join the boundary together, you join the template together, then you bring the template inside your boundary by moving it. You press and enter, or you come to this place to click on your move, so enter, then you select it. You can off the auto now, so that it will allow you to be able to put it at the center. Now this template, now this boundary now is inside the template of 1 in 500. So let's confirm that. You change it to ledger, and then you change this to millimeter, and then you change this to 0.5, that is 1 in 500, and then you window what you want to print out, then you click on it. Then after I click on it, you come to preview. Now you can see now using 1 in 500. So that is that on 1 in 500. So that one is in 1 in 500. You already know that you put your title, your everything here. What I'm just doing is how to set template for 1 in 500, whereby I told you the length is 156.638, and then the breadth is 96.872. If you want to convert this drawing, now let's assume this boundary that is inside this template is bigger than this template. Now you want it to be on 1 in 1000. So what you simply do is you select the template for 1 in 500. Let's assume you have the template for 1 in 500. You select it, then you right click and then you click on scale. Then after you click on scale, you're requesting to select the base point, so you select your base point. Now after you select your base point, what you simply do is on your calculator, you divide the new scale that you want to convert to, that is 1 in 1000. So you now see 1 in 1000 divided by the old scale, that is the previous scale, which is scale of 1 in 500. So what do you have? You have 2. So what you just press as a scale factor will be 2.0, then you press enter. Now you can see now this is now on 1 in 2000 scale. Let's move it away from 1 in 500. This is 1 in 500 scale. This is 1 in 1000 scale. So this 1 in 1000 scale now. Let's copy it. Let's copy it here. Let's assume we want to scale it. We want to scale this in a situation whereby the boundary that is inside this template now does not fit in. So let's confirm this 1 in 1000 scale that I brought in. So what you simply do is you come to printer and then you choose the printer that you want to use. So I've once used this printer before. So now you change this to ledger. Then after you change it to ledger, you make sure this one is in millimeter, and then you change this to 1. That is now in 1 in 1000. Then you window what you want to do. You window the template of your boundary. Then you preview. Now you can see now this is 1 in 1000. Now likewise, if this boundary does not is bigger than this template, I want it to be on 1 in 2000. So what you simply do is you select the whole boundary. You select the whole boundary with the template, and then you right click and then you click on scale. So you select the base point. Now after you select the base point, I told you earlier on that you divide the new scale by the old scale. So the new scale is in 2000 divided by the previous scale, which is in 1 in 1000. So that is 2000 divided by 1000. So that is 2. So you just press 2 as your scale factor, then you press enter. So it's not much bigger than the previous thing that you have. That is how to work on scale when plotting a plan. What you simply do is you have to be rescaling your template. You can as well change it from a bigger scale to a smaller scale. This scale as well, you can also convert, you can also change it back from 1 in 2000 to 1 in 1000. What you simply do is I told you a formula whereby the new scale divided by the old scale. So my new scale now, I want it to be on 1 in 2000. 1 in 1000. So what I'll do is I'll highlight it, then I'll now say 1000 divided by 2000. That is 0.5. So by the time I'll be inputting my scale factor, so my scale factor will be what? My scale factor will be what? 0.5. set your direction to north, then click OK, and you click OK. So we are plotting using polyline. In order for you to plot using bearing and distance method, you can either plot using polyline or line, but I'll be using polyline to plot. So to use a polyline to plot, is either we come to this place and select, polyline, or you can type in polyline here. PL, that is the short form for polyline, or you can just come to the screen and type P, so it will display list of what you have as P. So here is my polyline, then I'll select it. Now after that, you input your coordinates, you input your easting coordinates before your northern coordinates. Now I have my easting as 526.334.080, 1 comma, while my northern coordinate as 729.131.206. Enter. So now the next thing is to input your distance and your bearing. So in order for you to do that, you hold your shift and you press Alt. Shift Alt. The distance 36.68 is less than 31 degree 37 minutes. Enter. Shift Alt, that is the next direction, 19.00 is less than 120 degree 22 minutes. Enter. Shift Alt, that is the next direction, 36.39 is less than 211 degree 18 minutes. Enter. Shift Alt, 19.20 is less than 301 degree 00 minutes. Enter. Now I'm done with my bearing and distance, all the side I've input it. Now the next thing is, when you are done with your inputting, your bearing and distance, so you press C, enter, Z, enter, E, enter. Now the C, enter, Z, enter, E, enter is, C is for close, that is you are letting the system to decode that you are done with the input of the value. Y, Z, enter, it means zoom, and then the E, enter is extend, to extend the view of what you have on the screen. Now you can see, now this is my boundary. So let me give a color, let me change this color to red. Now this is polyline. This is plotting with bearing and distance method. Now I told you something the other time. I said for polyline you can check for the area immediately. Now the area here, what you want to check for the area, what you just do is to select the boundary, then you press LI, that is list. Now you can see, now here is my area, and these are the coordinates that was input. These are the coordinates, so you can just copy it back. That is how to plot using bearing and distance method. The next thing is to plot using coordinates method. So in order for you to plot using coordinates method, you just come to, is either you plot using polyline or you plot using line. Now to plot using line, you come to this place and click line, and then you click on create line. Or you can come to the screen, then you press L. So you can see now, either you press it finish, or you just press L. So let's select it here, or you can come to this place, you press L. This command here, you press L, so it will still display same thing. Then you press enter. Now it's asking us to specify the first point. So you input your coordinates, your starting coordinates, and you must make sure you are inputting the easting before the northing. So my easting value I have here 526.334.080, comma 729.131.206. Enter. Now it's asking us to specify the next point, but on my own screen here, the coordinates for me to plot my bearing and the coordinates for my parcel, I already have it on my notepad. I already listed it out on my notepad. So what I'll just do is, since I already have my coordinate on my notepad, that is easting here, comma nothing. So what I'll just do is to copy all these coordinates, and then I'll copy all these coordinates, then I'll come to this place, and then I'll paste the coordinates here, then I'll press enter. You can see now all the coordinates have been input into the system now, so you can see the values now. Then I press enter. So now this one is the coordinate, using coordinate method is plot with line. Now the difference between line and polyline, now you can see you have to be selecting it one after the other, compared to polyline whereby you just select it once. Now to check the area of the parcel now, well, if you should select everything now, LI, you can see what it's giving us. It's not giving us the area, and everything is scattered. Is because we plot using line. So in order for you to check for this type of thing, where you want to check for the area, all you have to do is you come to analyze, then you click on area, then you start from the corners of the boundary, then you return back to the starting point, then you press enter. Now you can see the area now. You can see the area using line method. So when plotting the difference between the line and polyline, you can see the difference now. The polyline method is faster than line method. So that is how to plot using bearing and distance method and using coordinate method. Thank you. Hello, welcome to my channel. Today I'll be showing you on how to convert Notepad data to Excel data. Here on my desktop here I have Notepad data. Here is it here. So these are the list of the coordinates. I have it on XYZ. If you want to edit data on Notepad, there are things that you can do to save time. Like if I want this thing to be on easting nothing, easting comma nothings, comma, height, comma. So what I will do is I'll space out this thing. I'll left click on my mouse, then I'll draw out the space here. Then I'll press Ctrl H. So it's going to display this page. What I want there is comma. I'll just click on replace all. So you can see now it has been edited properly. Instead of me doing it out one after the other, I'm going to be spacing it out. So this is simply what you can do. You just select the spacing between, then you press your Ctrl H, then you put in what you want to be there. Comma, I want comma to be there, so that is how I'm putting comma. Then I'll click on replace. So it's going to give me what I requested for. So that is how to edit on Notepad. But that is, by the way, what I'll be showing you is how to convert Notepad data to Excel data. So what you do is so this data I have on my Notepad now, I want to convert it on Excel to CSV. I will launch my Excel, then I'll click on open other workbooks, then you click on browse. So after you click on browse, you have to select the location where you have the Notepad data. So the location where I have my own Notepad data is on my desktop, so I'll click on desktop. Then here you come to this space, you click on all files. Then after I click on all files, then you select the data that you want to convert. So this is it here. I save it as data, then I'll click on open. Then after I click on open, I'll click on next. Then I'll select this semicolon, comma, space, then I'll click next, then I'll click on finish. Now you can see now it has converted it to, it's now on Excel where I have my listing notice height. Then I'll click on file and then click on save as, then I'll click on browse. Now I cannot change this to any save type format that I want. Now I want it to be on CSV command limited, so I'll click on CSV command limited. Then I can rename it here as data 2. Then I'll click on desktop, then I'll click on save. Yes, then I can close my Excel now. Now this is it here, this is it on the screen here. It's now on Excel. I've converted the Notepad data to Excel data, CSV data. That is how to convert data from Notepad to Excel. Thank you. Hello, today I'll be showing you on how to open description, listing notice and height on your AutoCAD point. How to view it. You will do that by coming to your point here. You will import your Excel data to your AutoCAD. You click on your point, you click on point creation tools, you click on this icon here, import point, then you select your Excel format. My Excel format, I'm having PENZ command delimited, and I'll click on this icon here, manage format. I will re-click on that format again, and then I'll click on modify. Then I'll set this as CSV because my Excel data is CSV. Then I'll click on coordinate zone transform, and then I'll set my region Nigeria, set my data region, and click OK, and then load the data. I'll change this file type to .csv because my Excel data is .csv, and then I'll select my data here and click open. Then I'll click on pass.
then I'll click OK and close this. Then I'll come to this plus sign at the top here. I'll change this to CSV as well. I'll select my Z data as well. Then I'll click open again and I'll click OK. Then after that I'll press Z, enter on the command here, and press E, enter. Now I have my point on the screen. Then I will come to the plus sign beside the points group here. I will right click on my all points and click on properties. I will change this point label style from none to nothing and easting, and then I'll click on this arrow sign here. I'll click on copy current selection and I'll rename this as DENZ, that is description easting nothing's height, and I'll click on layout and click on this A. I'll rename this as description, that is D, and this content beside it I'm having label text. I'll click on it, these three dots. I'll select this and change this point number to raw description, and then I'll click on this arrow here and click OK. In order for me to have this data on the same alignment, I will change this offset to 11.30. Like this, I will change to 3.40. Then I'll click on this A again and put Z there. This Z stands for my height, and then I will change this, click on this label star and select this. I'll edit this point number. I will change it to point elevation because we are dealing with height this time. Then I'll click on this arrow sign and click OK. Like I said earlier on, I will set this offset also in order to have my data on the same alignment. 8.50. Then I'll click apply. Then I'll click OK, apply, OK. Now you can see on my screen now I'm having my description, nothing easting height, description, nothing easting height at every point, description, nothing easting height, description, nothing easting height. Thank you.
Hi subscribers, welcome to my channel Survey Got Easier. On today's tutorial, I'm going to be sharing with you on how to plot a survey plan. As you can see here, we already have a sample on the screen here. So for you to plot a survey plan, we have two methods of plotting a survey plan. You can either use coordinate method or bearing and distance method. But the method I'm going to be adopting today is bearing and distance method. And reason being that because on this particular survey plan we're going to be using, we are given the bearing and distance of each point, and we also have the coordinate, just a single coordinate. So you must have a coordinate to plot, which we have been given on the plan. So that's why I'm going to be using bearing and distance method. If you want to learn how to plot using coordinate method, you can check out on my video on how to plot survey plan using bearing and distance and coordinate method. There is a video for that, but today I'll focus on bearing and distance method only. So if you want to plot using bearing and distance, so once you launch your AutoCAD, you can either plot using polyline or line. And what's the difference between polyline and line? If you are plotting with polyline, you are going to have it as one single polygon. If you are plotting with line, it's not going to be joined together. So what am I saying next? Let me quickly show you that. When you come to your command here, when you press L, L is the shortcut for line. You can see a line. Then you press enter. So now, if I should plot with line, this is what I'm saying. Enter. So now, if I should plot with polyline shortcut is PL. Polyline shortcut is PL. So you can see PL. Immediately I press PL, it's going to suggest for me, and then I'll press enter. PL enter. So plotting with polyline. Enter. Now this is polyline here. This is line. You can see the difference. Polyline we join everything together at once compared to line. Line we select it one after the other. But I'll be using polyline to plot today. Now on this survey plan, you can see now we are giving the coordinates. This is where the coordinates is coming from. This starting point. This is the starting point. And how did I know this is the starting point? Is because when you check this line here, it intersects here to this place, and the one below here is also intersects at the center here. That's why I know this is where the line is coming from. This is the origin where it starts from. So this is the coordinate of this particular point here, and this is the bearing and distance for the line from here to here to here. So we have to plot in a clockwise direction. We go clockwise. I'll be using polyline, so I'll press PL, enter. Now on the easting here, this E simply means easting, and this N means nothing. So starting with the easting, you're going to press it. Easting values we have 539.852.875, comma. So you check the notice value as well. You input the notice value 734.821.355. You make sure this command that is in between the easting and nothings, you make sure you put it there. Then once you supply the nothing values, you press enter. So the next thing for you to do now is, this is the starting point. This coordinate that we input, this thing and the notice coordinate we input is the starting point of this point. So we are moving clockwise. The next point we are going is this place, and to get there we have him to input the distance value and the bearing value. And the distance value is 7.91 meters, while this bearing values is 89 degrees 17 minutes. So to get that done, you come back to this place. You hold your shift at, you press shift at, you hold shift, you press at. So you now press the distance. 7.91 is the distance value. As you can see, 7.91. You ensure that the M, which represents the meters, you won't put it there. Don't put the M there. You just press the value 7.91. You now press, hold your shift, you press is less than. The bearing is what? 89 degrees. B represents the degree. 89 degrees 17 minutes. So that's the value, the bearing and distance for this particular line here. So once you input the bearing and distance, you press enter. Alright, so the next point now is this side. The next side we are going is this side here. The distance is what? You hold your shift, you press at, shift at. What's the distance? 31.64 is less than what? Is less than 177 degree 30 minutes. Enter. The next point is what? Which is this? 8.12. Shift at. Don't forget, you always put you always put at before the distance. At what? At 8.12 is less than 269 degree 14 minutes. Then you press what? You press enter. Now the next side is what? Which is this side here. We have what? 31 point shift at. When you hold your shift, you press at what? At 31.65 is less than 357 degree 53 minutes, which is here 357 degree 53 minutes. So after you put it, you press enter, and once you are done, you can see now we started from this point, we move clockwisely, and we come back here. Since you don't have any points, any values to repeat again, since you are closing here, you know you started from here, you also have to close here. Then you now come to this place, you press C. C means close. You press C, enter. You now press what? You press Z. Z means what? Z means zoom. Enter. It's because you can see the password that I plot here. And the last thing you press is E. E means zoom extent. Enter. Now you can see now, immediately I press the E, which is the zoom extent, it will take you directly to what is plot on the screen. If you are far away from that point, it will move you there immediately. That's the purpose of C, which is close, enter, Z, which is zoom, enter, and E, zoom extent, enter. And that's how to plot using drawing and distance methods. Should in case you want to learn how to plot using coordinate method, you can check my videos on my channel Survey.easier on how to plot using coordinate method. I also have the videos there. Now these are other informations on the screen. Now when you select this boundary that we plot now, you now right click, you copy, you click on copy, or you come to the command below here. You come to the command below, you press CO. CO simply means copy as well, but that's a duplicate copy. So all I'll do is to select where I want to pick the copy from, where the base points to copy. I'll just select here, I'll place it here. So after I copy now, what I'll do is to move it. To move that, you come to your command there, you press M, or you press MOVE. M is the, you can see move. Then you select the base where you want to move to, from to. You move to the point you want to move to. You can see now there is something that was put here. You can see that is how they were able to achieve that, or there is a particular information that was supplied to plot the boundary beside the one we have, the information bearing and distance. But because we have any information here, we don't know the actual length of this area here. Now the next thing is road. Now to do that, all you're simply going to do is to press your polyline. You press PL under your command there, you press PL, enter, and you select this place. You select here and you select here. Alright, so now you select what you just plot. Now that line you just plot, you select it and you come to this place, you press, you can see O offsets, and it's going to ask you what's the distance of the offset that you want to make the offset to be. The distance, let's just use 5 meter offset. So I'll press 5. You can see this 5 now. I'll press enter. Now it's asking me, is it going to, did I want it to be below or above? I'll just select above, and that means I've represent an offset over there. If I want the offset to be in 1 meter offset, I'll just press my O as offset, and I'll press 1 meter offset. I'll press 1, enter. Now I'll put the offset here. You can see now we are already getting something, information there. That's the concrete drainage and the road provided on the plans. Alright, if you want to bring in the information that was provided on this plan now, that is not to provide the northern and eastern values. As you can see, this place was represented as the origin. For me to do that, what I'll do is I'll press PL. PL is the polyline, enter. And I'll select where I want my polylines to be. I'll make sure my auto is turned on, because auto will make it to be very straight, to give me a perfect straight line. Now this is it here. I will draw a circle now. This circle now, what I'll do is to hash it by selecting it, and I'll press H. H we make me to arch it. Once I press H, enter, that's for hashing. Now it's going to ask me bring out this information, and I'll select this place to hash the circle, and after arching it I'll press escape and I'll select it. I'm going to press SC. SC is to scale the circle. So what I'll do now is to reduce the size to have a smaller size. Now I'm going to do something inside this square now. Just watch what I'll do. I'll press PL, polyline, enter. So I'll select this and I'll press M, enter. That is to move this hash values now. I'll remove this from auto so that I'll be able to move that, and I'll place this here. Now you can see now what I'll do now is to move the entire square by selecting and press M, enter, and I'll bring it to the actual place it's supposed to be, which means that the coordinate is starting from this place and we move round. So now for you to provide other informations, like maybe you want to type something or whatever you want to do, it's quite easy for you to do that. So for you to do that, you come to this, you click on this annotate icon, or you come to annotate here and you click on this multi-line text. You select multi-line text and you come to this place, you select it, and under this place here you supply in any details you want to put, like 89 degree. You hold your shift, you press 55D. So that is going to give you what degree, and what 17 minutes. We have what, you press enter, we have the values below, which is what 7.91 meters. You come to this place and you align it well. So once you are done, you just click outside the box, but it's too small for us, so you select it again, you right click and you select it, right click and change the text height to like something you can use like 1.2, and you click outside it. So now this will be here, you select it and you move it inside this place, and that is how to bring out information. You can just copy this value now, Ctrl C, or you press C, enter, Ctrl V, and you put same thing here, and you put same thing here. So you double click on this and edit it properly. As you can see, we have what, just cut out the, so here we have what, here we have 8.12 meters, and this is 269 degree, 14 minutes, then you press enter. So also same thing applies to this space. You select it and give it the information as well as the coordinates values, CO, enter. The coordinate value is the eastern and the northern for the coordinates. So for the coordinate now, Ctrl A, we have the coordinate as 734 space 821.355 meter north. That's for the northern, and for the eastern you select, we have it as 539.852.875 meter east, So that's for this thing. You can rotate if you like to have exactly what was displayed for you. You can rotate and you move it down. And when you watch my videos on how to prepare, when you watch my videos on how to plot a survey plan, A to Z process of plotting survey plan is well detailed. Both the information you need to supply, how to go about it, everything is detailed on the videos. And I believe by now you should be able to plot a survey plan using blend and distance method. And if you found this video helpful, do want to subscribe to my channel, like my video, share. Thank you. Hello, welcome. Today I'll be showing you on how to save your drawing to PDF file. In order for you to save your drawing to PDF file, what you will do is that after you're done with your work, then you come to plot, you click on this plot, or you press Ctrl P, then you click continue to plot a single sheet. Then after that, you set the paper size of the PDF file that you want. I mean the paper format that you want. Either you want the print to be on A3 paper size when it's going to be printed out, or you want it to be on A0, or you want it to be on A4 paper, or any paper format type that you want. You have to select it here, so that by the time you be setting it to PDF, it's going to be on that paper format. But I'll be using A3 paper format as an example. So the first thing you will do is you come to printer plotter, then you set this to DWG to PDF, and then you, let's assume I want to use select out this page. I want the print to be on A3 paper format. So I'll just click on this and then I'll select ISO. I'll select ISO A3. So we have ISO A3 420 by 297 and ISO A3 297 by 420. But I'll select ISO A3 420 by 297. That is on okay. The other one is on portrait. Why ISO A3 297 by 420 is on landscape. This is on landscape. Why this? The first one is on portrait. So I'm using the first one since it's on portrait. And you can as well come to drawing the orientation here. You change it to portrait or landscape, any paper format type that you want. If you want it to be on landscape, you click on landscape. And if you want it to be on portrait, you click on portrait. And then the next thing for you to do is if you want the drawing to be on fit to paper, you click on fit to paper. And then you click on